Not because nothing was happening, but because no one on Earth could see it. Solar glare, orbital alignment, and atmospheric interference had shut down nearly every major observatory at the exact moment something extraordinary was passing through the inner solar system. Yet one observer remained unaffected. Far from Earth, circling Mars in quiet precision, a single spacecraft continued to watch without interruption. That spacecraft was Tianwen-1. While Earth-based telescopes were blinded by the Sun's position and Western space agencies were forced into a tracking blackout, Tianwen-1 occupied a rare geometric window. From its Martian orbit, it had an unobstructed line of sight into interplanetary space, free from atmospheric distortion and solar interference. During the critical days when interstellar object 3I, ATLAS approached perihelion, Tianwen-1 never looked away. What it recorded has now been released, and the implications are unsettling. The first images appear unremarkable at a glance. A faint object surrounded by a hazy envelope, drifting against the black. But closer analysis tells a very different story. The coma surrounding the object was not thinning as expected. It was becoming denser, brighter, and more symmetrical. Instead of dissipating under solar stress, it stabilized. Instead of fragmenting, it held together. Brightness measurements revealed values far higher than predicted by any existing comet model. Even more unusual, that brightness was not random. It fluctuated rhythmically, following a repeating pattern. Periodic behavior in an interstellar object is rare enough, but the amplitude of the variation exceeded what a small, inert nucleus could physically produce. Either the object was rotating far faster than expected, or it was responding to energy in a way that classical physics does not account for. As Earth's observatories remained blind, Tianwen-1 watched new structures emerge. Jet formations appeared and evolved in real time, not as chaotic sprays of dust, but as coherent, directed streams. The dust tail stretched rapidly, forming a pronounced anti-solar plume that extended millions of kilometers. Its growth rate exceeded all prior simulations. This was not passive sublimation. It was organized release. According to long-standing models, behavior like this near the Sun should lead to rapid fragmentation. Thermal stress, internal pressure, structural weakness, something should have failed. But nothing did. The nucleus remained intact. Photometric analysis revealed a paradox. The object exhibited the energy output of a body breaking apart, yet visually retained the structure of a single coherent mass. Under known cometary physics, this should not be possible. To sustain jets of that magnitude without disintegrating would require internal surface area far greater than what a solid body of that size could possess. Unless the object was hollow, or layered, or internally structured, or something else entirely. Every instrument aboard Tianwen-1 independently confirmed an even stranger detail. Embedded within the coma was a region of suppressed reflectivity. Not a shadow, not dust interference, not an imaging artifact. A distinct, repeating feature aligned with the object's axis and jet orientation. A dark ridge, consistent across multiple exposures, suggesting internal geometry rather than randomness. Then came the observation that unsettled even the most cautious analysts. A sudden increase in brightness occurred on the side facing away from the Sun. Comets do not behave this way. Sublimation happens on the sunward side. Energy input comes from direct heating. Yet Tianwen-1 recorded a clear luminosity increase from the cold hemisphere, as if activity were being triggered internally rather than externally. The Chinese research team referred to this as a photometric inversion, an event with no accepted explanation under current models. Something inside the object appeared to activate in response to solar input elsewhere. Once the data was released, agencies around the world began reconstructing the missing observational gap. But the tone of the analysis was noticeably restrained. Almost somber. There was an unspoken recognition that Earth had not been the primary witness to this event. For the first time in modern astronomy, the decisive observations came from another planet. The jet morphology did not match any Western simulations. The brightness curve altered the orbital solution. The lack of fragmentation contradicted the measured acceleration. The dust geometry was incompatible with a single solid nucleus. The object had to be fragmented, hollow, internally complex, or governed by physics we do not yet understand. No report stated it outright, but the implication was clear. This object is not behaving like a comet. The final pages of the document shift in tone, reflecting on the irony of the moment. An object older than the Sun itself, passing briefly through our system, was observed most clearly not from Earth, but from Mars.